There are no operating restrictions on the use of derate. Derates may be used at any time under any circumstances, provided, of course, that the expected takeoff weight is low enough to allow the use of that lower thrust rating. In fact, there is a special circumstance when derate can be used to increase the performance limited takeoff weight. That can occur when the runway is short or when the braking performance is reduced because the runway is wet or contaminated with standing water, slush, or ice. Strange as it sounds, it's true that less thrust can offer higher takeoff weights under certain circumstances. Let's see how this works. First, when using derate, all the performance information is computed at the lower derated takeoff thrust. This includes the limiting takeoff weights and takeoff speeds, including the minimum control speeds. Under normal circumstances, this lower thrust will result in a lower fuel length limited weight, which is what you expect. Note, however, that this reduced thrust will result in a lower minimum control speed on the ground. Since derate thrust is less than maximum thrust, there's less thrust asymmetry, and therefore the rudder can offset this lower asymmetry at a lower speed. Recall that there is a minimum fuel length required to accelerate to this minimum control speed and then be able to stop. Because the minimum control speed with derate is lower, this minimum fuel length is reduced. As you can see from the chart, this can result in a higher takeoff weight when using derate. Practically speaking, this advantage of using derate is only realized when the runway is wet, contaminated, or extremely short.